Okay, students, welcome back to the next topic, that is from the living world. Okay, so the introductory part of the living world we successfully finished. Next topic is nomenclature. Nomenclature. See here, nomenclature. Generally, nomenclature is to avoid the confusion and to give standardize the naming of the living organisms. Scientific names are given to the living organisms. Okay, here generally the process of giving, see here the process of giving scientific names to organisms, scientific names to the names to organisms is called nomenclature. Okay, so for example, here the common name of certain plants in different languages in different, for example, China, China rose in English, Gurhal in Hindi, Padmacharini in Sanskrit. So like this way, one organism has different names. See, China rose, hibiscus, Rosa sinensis. So its name in English is China rose, in Hindi Gural, Sanskrit Padmacharini. Like this way, in different languages, different names are available for living organisms. If these names are used to identify the living organisms, we will get confusion. So to avoid this confusion, so scientific names are given to the living organisms. That process is called nomenclature. The process of giving scientific names to the living organisms is known as nomenclature. So due to these scientific names, same names are used in English. Okay, so with these scientific names, we can avoid confusion in different languages. Next important term for giving nomenclature, for giving scientific names is identification. Here see identification. See here the study of diversity of organisms. The study of diversity of organisms is possible only if you know each and every organism and are able to identify them easily. So when we are able to identify the living organisms on the basis of their external features, it is easy to give nomenclature. So here, second step of nomenclature is identification of living organisms is important one. Next important step is classification. See, all around ourselves, we see many kinds of plants and animals. Many kinds of plants and animals. They all exhibit various degrees of resemblances and differences. Okay, the method of arranging and grouping of organisms into various divisions are called classification. So classification is very important step for nomenclature. In this one, what we have to do, the method of arranging and grouping of organisms into various divisions on the basis of their external features. This phenomenon is called classification. Taxonomy. Next important step is taxonomy. So generally taxon means arrangement. Nomi means law. Okay, according to the universally accepted rule, the living organisms are arranged into specific categories. So it deals with identification and classification of organisms. Classification of organisms. This phenomenon is called taxonomy. So for taxonomy, first step is identification of the living organisms on the basis of their external features, living habitats and food habitats, and classification of organisms. So on the basis of their features, dividing plants and animals into different classes. That phenomenon is called taxonomy. Generally, based on the characteristic, all organisms can be grouped into different taxa. Taxa means category. So the process of classification is called the process of classification. The process of classification is called taxonomy. The process of classification is called taxonomy. Okay, so that is the step of the taxonomy. Next, after this one, here the scientific next topic is systematic. Systematics means so body of techniques for investigating different kinds of organisms. So here the scientific study of the kinds. Scientific study of the kinds. So scientific study means what? Systematically studying the different kinds of living organisms and diversity of living organisms. Diversity of living organisms means what? Here differences in between the living organisms and existing relationship among the living organisms is termed as systematics. Okay, so here the scientific study. So scientifically different kinds of living organisms studying and differences of the living organisms. So what kind of relationship is existing in between two organisms? That phenomenon is called systematics. Here the term systematics is derived from Latinized Greek word. So it is in this one systema meaning classification. Systema meaning classification of organisms. Okay, the word was used by this word systematics used by Carolus Linnaeus, and he published about this systematics in his book Systema Naturae. Okay, so this is the information about systematics. Here about some taxonomy. Treat taxonomy and systematics. As similar terms, but in reality these are two different terms. Taxonomy is different, systematics are in reality different terms, but some scientists believe that these two are indicates same meaning. Okay, so taxonomy deals with the study of living organisms. And their classification. Whereas systematics deals with study of living organisms and their relationship. So this is the actual meaning of taxonomy and systematics. Next binomial nomenclature. Binomial nomenclature. See here, binomial nomenclature means binomial, two names, giving two names to the living organisms. Actually, scientific made several attempts in the field of nomenclature, but the most acceptable and most workable system of nomenclature was proposed by Carolus Linnaeus. Carolus Linnaeus. He proposed two names to the organisms. Two names. He proposed to name the organisms two words. He proposed the name the organisms with two words. Two words. One word is species name. Another one is, first one is generic name. Generic name. Another one is specific name. So this is called binomial system of nomenclature. So see here, generally this binomial nomenclature was first published by Carolus Linnaeus on 1st January 1758 in his book Systema Naturae. Systema Naturae. Okay, that's all. The scientific names, giving scientific names to the living organisms ensure that each organism has only one name. Each organism has only one name throughout the world. It can avoid the confusion to identify the living organisms in different languages. Okay, next here, there is two organizations, that is International Code of Botanical Nomenclature and International Code of Zoological Nomenclature. These are two organizations, so which provide a stable method of naming to the living organisms and avoiding the use of names which may cause error or confusion. Okay, so here some of universally accepted principles to be followed to give the names to the living organisms. Those universally accepted, some of the universally accepted principles here we will see. So the first universally accepted principle is, see here, so the scientific names of each species is binomial name. This is made up of two parts. Binomial name is made up of two parts. The first word is generic name. And the second word is second word is specific name. For example, scientific name of human being is Homo sapiens. Homo sapiens. Homo sapiens. In this one, Homo is a generic name, sapiens is a species name. Okay, these two names are given to the living organisms. This is the first universally accepted principle. Next one is, second one is, the scientific names are generally Latin and should be in italics if printed. And those scientific names are separately underlined if handwritten. Should be separately underlined if those scientific names are handwritten. Okay, so third universally accepted principle is, the generic name should always begin with capital letter. Generic name means what? Letter, next we will see, with a capital letter. But the specific name start with a small letter. For example, here see example we will see here, name of the plant mango. So the mango plant, scientific name of mango is Mangifera indica. In this one, Mangifera, it is a generic name, it is started with capital letter. Indica, it is a specific name, it is started with small letter. So this is the third universally accepted principle. Next, fourth one. So name of the taxonomist, name of the taxonomist, name of the scientist. Those names should be added at the end of the specific name. For example, here Mangifera indica, Mangifera indica. Here, so if this scientific name Mangifera indica, who have given the scientific name, their taxonomist name here we have to add. For example, if the scientific name is given by the Linnaeus, then we will give the Linnaeus name in abbreviated form at the end of the indica. Okay, it is a generic name, it is a species name, it is Linnaeus scientist name we have to add at the end of the specific name. Okay, so like that. Next, fifth one. If the words are taken from any other language, if words are taken, from any other language, other than Greek or Latin. So at that conditions, they are Latinized with the suitable endings. They are Latinized with suitable endings. Okay. For example, see banyan tree. If you take example, banyan tree. So banyan tree. Okay. So banyan tree scientific name is obtained from the Bengal. That's why it is called. So Ficus bengalensis. Ficus. It is a generic name. Bengalensis. Like this way, that Bengal. Okay. So banyan tree is available in Bengal. So from that language, this scientific name taken. So that so Ficus bengalensis, where bengalensis means from Bengal, where it is commonly found. Bengal, where it is commonly found. Okay. Next, last and final universally accepted principle. The organisms belonging to two different genus. The organisms which are belongs to two different genus can never have the same generic name. However, the species name can be repeated many times. For example, scientific name of the mango, Mangifera indica. In this one, Mangifera generic name, specific name is indica. Like that, scientific name of tamarind. In this one, the scientific name of the tamarind is Tamarindus indica. In this one, Tamarindus is a generic name, indica is a species name. So species name can be repeated in some plants, but generic name cannot be repeated. Okay, like this way, before giving to the living organisms scientific names, we have to follow these 6 universally accepted rules. So this entire phenomenon, this entire process is called binomial nomenclature. Okay, binomial nomenclature. Okay, next topic, hierarchy of categories. Hierarchy of categories. See, in this one, the organisms are placed in various categories, which include specific relationship. So the organisms which have closest relationship, those are all organisms are placed into various categories. Here, the living organisms are grouped together by certain similarities, certain similarities that show how one group is related to another group and how the modern day organisms have evolved. So this is called hierarchy of categories. Generally, the living organisms are grouped together by certain similarities. The organisms which are living in aquatic habitats and terrestrial habitats are on both the living places, both the places which organisms can survive. On the basis of the living habitats are grouped together by certain similarities that show how one group is related to another, and how modern day organisms have evolved. Okay, that's all. Next, the putting up of the taxonomic categories in a logical sequence. All the living organisms are putting into a logical sequence. This phenomenon is called hierarchy. Hierarchy. Okay, that's all. Putting above the living organisms in a logical sequence is called hierarchy. So hierarchy is a system of arrangement of classification. So the hierarchy of categories, hierarchy of categories consists of descending sequence of 7 obligatory categories. 7 obligatory categories. They are kingdom, next phylum, next class, next order, next family, next genus, finally species. Like this way, 7 obligatory sequences, 7 obligatory descending sequences. Okay, descending sequence. From kingdom to species, the number of characters are decreased. Okay, that's all. In these 7 obligatory sequences, the first, if we will see from lower to up, from species to kingdom, we will get an idea about how these taxonomic categories are linked together. So in those taxonomic categories, first one is species. Okay, so it is the not only the basic unit of taxonomy. Generally, species is not only basic unit of taxonomy, but also helps in the evolution of species. So first of all, let us see the definition of species. A species includes a group of organisms, group of organisms. So which closely resembles and freely interbreed with each other. Each other. So they have more resemblances and among themselves can freely interbreed with each other. Such kind of organisms are called species. Okay, this is the definition of species. If we will see here, a species is always recognized by scientific organisms. So here, if you will see example about species, scientific name of lion is Panthera leo. In this one, in the scientific names of the organism, the first word represents with the genus name, while the second word represents with the specific epithet. For example, another plant scientific name is mango. In this one, Mangifera indica. In this one, Mangifera is a generic name, indica is a specific name. Okay, that's all. Next, in such a, if we will see another scientific name of the plant is potato. Scientific name of potato is Solanum tuberosum. tuberosum, Solanum tuberosum. In this one, Solanum is a generic name, tuberosum is a specific name. So in such a way, the word indica, tuberosum, and Leo, these three represents specific epithet, whereas Panthera and Mangifera and Solanum represents generic name. Next here, similarly, scientific name given to humans is Homo sapiens. Homo sapiens. In this one, Homo represents genus. Sapien represents species. Like this way, species are represented with closely resemble characters. Okay, that's all. Next topic is genus. So first one is species. Next one is genus. In this taxonomic categories, the lowermost category is first species. Next genus. So among the species, closely resemble characters are more. Okay, so comparatively species in genus, closely resemble characters are little bit decreased. Here 10 characters are similar, here 9 characters are similar. So if you will see genus, a group of organisms, a group of closely related species, closely related species is called genus. So the common features are called correlated characters. So these may be very prominent and significant in living organisms. So generally each species is given two names. Okay, that is already know that generic name and specific name. Here, example, if we will see, scientific name of lion is Panthera leo. Next, scientific name of leopard. So Panthera pardus. Here, scientific name of tiger. Panthera tigris. Okay, so these three different species, Leo, Pardus, tigris, these three are different species, but belongs to the same genus. Panthera. Genus Panthera differs from another genus, Felis, which include cats. Similarly, in plants, if we will see, scientific name of potato is Solanum tuberosum. Next, scientific name of brinjal. In this one, scientific name is Solanum melangina. Here, species is different, but genus name belongs to the same. This is called genus. Sometimes a genus may consist of only one existing species. For example, modern man, Homo sapiens. In the genus, Homo is single. In such a way, sometimes genus may consist of only one existing species. So the next, so first species, genus, family, order. So the related families are placed together in the same order. So order being higher category, generally order being higher category has families that exhibit few similar characters. characters. Already here we discussed species. In this one, 10 similar characters. Genus, in this one, 9 are similar characters. So family, in this one, 8 are similar characters. So order, in this one, 9 are similar characters. Like this way, gradually the similar characters from down to up decreased. Okay, ma? That's all. Next, if you will see, generally order and other higher taxonomic categories. Generally, order and other higher taxonomic categories are identified based on the aggregate characters, common characters. Okay, that's all. Next, here, if you will see examples, so the similar characters in order are commonly less. See, comparatively different genre in family. Okay, in this order, similar characters are comparatively less in number as compared to different genre in family. So, for example, if you see, an order has a number of families, and order has number of families. Number of families. For example, here you see order Carnivora, order Carnivora, Carnivora, order Carnivora. It includes family Felidae. Felidae. In the Felidae, lion, cats, and family Canidae. Canidae. It belongs to the dogs. So the order Carnivora, order Carnivora, family Felidae, Canidae. So family Felidae and Canidae belongs to the order Carnivora. In plants, this is what in animals. Animals order like this way. In plants, if you will see plants, in the plants order Polymoniales. Polymoniales. It includes family like Solanaceae and Convolvulaceae. It is a family. So family Convolvulaceae and Solanaceae both are belongs to the family, both are belong to the order Polymoniales. Okay, order Polymoniales belong to the family Solanaceae and Convolvulaceae. These two are families. Solanaceae, Convolvulaceae. These two are belong to the order Polymoniales. Okay, this is what explanation about order. Next, class. Here, if you will see class, the related orders, the related order are placed. Related are placed together. Related are placed together in the same class. In the same class. For example, each class has number of orders. The orders are related together by some common features. Some common features. For example, so class Mammalia. The class Mammalia has order Carnivora. In this one, lion, cat, dog included. Okay. Next, and order primates. In this one, man, gorilla, monkey. Okay. See, class Mammalia belongs to the order Carnivora. And order primates. Order primates. That is what man, gorilla, and monkey. So these are all belongs to the class Mammalia has order Carnivora and order primates. Next, here order Carnivora, if you will see order Carnivora. Order Carnivora. In this one, order Carnivora, lion, cat, dog. These belongs to the class Mammalia. Okay. Mammalia. Next, here, see order herbivore. Order herbivore. order herbivore, that is rat and rabbit. Next order primates, that is man, gorilla, monkey. These are all order species. These are all consists of class Mammalia. Mammalia means what? Includes all animals have mammary glands. Mammary glands, external ears, external ears, and body covered with hair. Okay, these are all order belongs to the class Mammalia. Okay, ma, that's all. Phylum. See, the related clauses are placed together in the related classes are placed together in the same phylum. Okay, for example, here you see class, pieces, that is fishes. Okay, next class amphibia, aves, and mammalia are put together in the phylum Chordata. These are all put, the class belongs to the pieces, that is fishes, amphibia, aves, mammals, all belongs to the phylum Chordata. Okay, so phylum Chordata, the phylum Chordata has all animals that possesses notochord. Notochord means backbone, and dorsal halo portion. Dorsal halo neural system. Okay, so if you will see here, in plants we will not call phylum. Instead of phylum, in plants the related classes are put together in a higher category. Related classes are put together in higher category. This is called division. Okay, in case of plants we will call division. In case of animals we will call phylum. Okay, next one is kingdom. So it is the highest taxonomic category. So in the taxonomic category, top is category is kingdom. So each kingdom has number of phyla. It includes all organisms. In phyla, it includes all organisms that share a set of specific common characters. For example, here all animals belonging to various phyla. They have been put together in kingdom Animalia. Similarly, in plants, if you will see in plants, so similarly in plants, so plants have been placed in kingdom Plantae. So all living organisms have been put into all living organisms have been put into 5 different kingdoms. Those are Monera, Protista, fungi, plant, and Animalia. Okay, that's all. So next, here the taxonomic categories from species to kingdom. are an ascending order. Lowest being species, highest being kingdom. From up to down is descending. From down to up is ascending order. Suppose species, genus, family, order, class, phylum, like that. Phylum and kingdom. Okay. Next here, see, as we go higher from species to kingdom, the number of common characteristics are decreased. From species to kingdom, the number of common characteristics are commonly decreased. 10, 9, 8, 7, 6, 5, and so on. Okay, lower the taxa, more closely related to related the organisms are to each other and share common characteristics. Higher the taxa, lesser is the number of common characteristics among the organisms. Okay, that's all. This is the explanation about hierarchy of taxonomy.